Hello, welcome to our Conrad investors pitch for a product designed to combat the effects of invasive marine species. I'm Isaiah Wang.
And I'm Clara McAllister.
So, our product. The name of our product is TISE, Targeted Invasive Species Eliminator. So, what exactly is the purpose of our product? Well, as the name implies, it's a product designed to target and eliminate invasive marine species, for example, lionfish in the Atlantic Ocean or crown-of-thorns starfish in the Great Barrier Reef. Invasive species cause huge amounts of damage to natural ecosystems by disrupting food chains, outcompeting other fish, other creatures, and just in general messing up the delicate balance of any natural ecosystem. They also incur lots of economic damage. A study by the National Invasive Species Information Center in 2005 estimated that in the US alone, $120 billion are lost per year due to the effects of invasive marine species. Therefore, our product is designed to help combat these negative effects and help restore the local ecosystems and economies back to their natural state. Now, how does our product work? Well, first of all, it is an AUV, also known as an autonomous underwater vehicle, and as the name implies, it's completely autonomous. So, we do have an AI in it, and this AI sees using the camera at the tip of the AUV. And this AI also has a program that, 1, allows for navigating without crashing into objects, and 2, is the hunting algorithm. And the hunting algorithm also utilizes the one minor modification that we added to this AUV, which is the killing mechanism or the spear and lethal injection. With all of these combined and a GPS, this AUV is able to autonomously navigate around coastal coral ecosystems, hunting and eliminating invasive marine species, and when battery life is reached, return back to the owner or designated port. So, what are the scientific merits behind our product? Well, in terms of the mechanics and hardware, existing AUVs are a good proof of concept. They're able to avoid obstacles, have a long battery life, can be tracked very easily. Overall, the standard functions of our AUV have already been in the market and widely used in industry and research. The new hardware that we would be using would be the hunting mechanism, specifically the harpoon and the syringe. And while no market product for our purposes, that is to hunt invasive marine species, has been created, the technology behind harpoons and syringes is so well developed that it would not be very difficult to repurpose them for our uses. Now, when it comes to software, that's where it's a bit more complicated, especially in the hunting AI. Now, while no previous AI has ever been developed that specifically hunts down a prey, it's not very difficult to imagine such an AI being possible. With a bit more development, as seen in self-driving cars and in AIs that can identify organisms, it's very likely that we'll be able to develop a program that can accurately hunt down fish and other invasive marine species within the next couple of years. Here we can see a simple CAD design of our product. As stated, it is in the standard AUV model with jet propulsions on the back and rudders on the sides for controlling steering, and the harpoon you can see is near the front, and with a flat face on the main body for lenses and sensors. Now, this is the standard model, but it's most likely to change after lots of testing and optimizations, but this is the standard model and what we would be basing all of our modifications off of.
And now onto our business analysis. There are no current devices or products that are similar to our product and or have a patent. There are few other products that are currently being developed. However, they either don't have patents and or aren't as good as our proposed device. Our product has more versatility and autonomy than others, which also makes it better. Its autonomy makes it more efficient, and its versatile killing methods help it kill more types of invasive species and also with more efficiency. When it comes to bringing our product to the market, we would have to license a manufacturer to produce our product since we cannot make enough on our own. Main sales would come from government contracts, fisheries, small coastal communities, and conservation/nonprofit organizations. Our product would also help simplify small commercial niches in catching and selling lionfish and starting in lionfish markets because lionfish are especially difficult to efficiently fish. When it comes to the cost, we are going to need around $800 to attend the Conrad Summit Challenge. That's $300 for food and hotels for 3 nights. On to the costs for the project itself. While we don't know industry prices, at most we predict $70 per production for each unit, but that's at the highest. A conservative estimate of sales would be 3,000 AUVs per year, but we would expect actual sales to be higher. Shipping 3,000 units at $20 per unit would be $60,000 in shipping costs. Assuming we sell at just 150, which is low for a product like this, we would have a $150,000 profit margin. But these are just very rough estimates as we took the highest values for cost, which is shipping and production, while taking the lowest income values, units sold, and price per unit. So the actual profit margin is probably much higher and spending is probably lower. Now in terms of funding, in the initial stage of production, we intend on small-scale fundraising through our school and the bioengineering club that we are both members of. We would ask for donations from our friends, family, and school. Later in the process, we intend on gaining government funding since the government would have interest in the environmental prospects of our product. A final method of funding is through private investors and angel investors who could provide a significant amount of money. Thank you for taking the time to listen and consider our product. We hope you are interested in what we have presented and we are excited to hear your feedback.